Overview of the batch publishing strategy. The batch publishing strategy involves sending messages in batches and waiting for the entire batch to be confirmed before proceeding. This approach allows for retries to be performed on batches rather than individual messages. Steps involved in using the batch publishing strategy. To utilize the batch publishing strategy, the following steps can be followed. Handling of confirms and retries in batch publishing. For each batch of messages, await the confirmation for all messages in the batch before proceeding. If all confirms for the batch are positive, publish the next batch of messages. If any negative confirms are received or the timeout is reached, determine whether to republish the entire batch or only the relevant messages. Handling of confirms and retries. In the batch publishing strategy, it is necessary to wait for confirms for the entire batch of messages before proceeding. Some client libraries provide convenience API elements to simplify waiting for all outstanding confirms, such as the channel.waitForConfirms timeout method in the RabbitMQ Java client. If all confirms for a batch are positive, the next batch of messages can be published. However, in the event of negative confirms or a timeout, appropriate actions need to be taken, such as republishing the entire batch or selectively republishing relevant messages. Potential negative effects on publisher throughput. It is important to note that waiting for confirms can have negative effects on publisher throughput. The time spent waiting for confirms introduces additional latency and can impact the overall speed at which messages are published. However, the impact on throughput is generally mitigated by increasing the batch size. Larger batches result in smaller relative effects on publisher throughput. Considerations for choosing the batch size and balancing throughput implications are essential to optimize the performance of the batch publishing strategy. Please remember to adjust the batch size and other parameters according to your specific requirements and performance considerations. Here's a quick summary of the notes for each node in the batch publishing advanced diagram on the right-hand side. Enable publisher confirms. This node represents the step where the publisher confirms are enabled on the channel. It ensures that acknowledgements will be received for each message batch published. Publish message batch. This node signifies the action of publishing a batch of messages. It is the step where multiple messages are sent together for processing. Await confirms. This node represents the waiting phase for acknowledgements. After publishing a message batch, the system waits for all outstanding confirms to ensure successful delivery. Publish next batch. This node represents the next batch of messages to be published. It is triggered once all confirms for the previous batch have been received. Negative confirms or timeout. This node signifies the occurrence of negative confirms or when a timeout is reached during the confirmation process. It indicates that some messages in the batch may have failed to be delivered successfully. Republish batch. This node represents the action of republishing the entire batch or only the relevant messages that failed to be delivered. It allows for retrying the failed messages to ensure their successful processing. Let's break down the code in the order of execution and explain how it incorporates batch processing functionality. The batch processing functionality is incorporated in the perform_batch_processing and handle_batch_processing functions. The perform_batch_processing function sets up the necessary RabbitMQ connections and configurations, defines the message batches, and calls handle_batch_processing to process the batches. Let us walk through this function. Establishes a connection to RabbitMQ and creates a channel. Declares the queue named my_queue. Enables publisher confirms on the channel. Registers the handle_confirmations function as the callback for acknowledgements and negative acknowledgements. Defines a list of message batches to be processed. Initializes the message_map dictionary to store message confirmations. Calls the handle_batch_processing function to start the batch processing. closes the channel and connection once all batches are processed. The handle_batch_processing function iterates through each batch, calls publish_batch to publish the messages, and waits for the confirms to be received by continuously processing data events. This allows for batch publishing and confirmation handling. Handle_batch_processing channel batches function loops over each batch in the batches list. Inside the loop, it calls publish_batch channel batch to publish the messages in the batch to the queue. Loops through each batch in the batches list. Calls the publish_batch function to publish the messages in the current batch. Waits for all confirms in the batch to be received by continuously processing data events using channel.connection.process_data_events. This function demonstrates how to publish a batch of messages to RabbitMQ using the channel.basic_publish method. It sets the delivery mode to make the messages persistent and keeps track of the published messages using the message_map dictionary. Loops through each message in the batch. Publishes the message to the my_QQ using channel.basic_publish. If the publishing is successful, stores the message in the message_map dictionary with its delivery tag. Prints a success message if the message is published successfully. Otherwise, prints a failure message. Handle_confirmations demonstrates how to handle acknowledgements and negative acknowledgements received from RabbitMQ. It checks the type of acknowledgement received, removes the corresponding message from the message_map dictionary, and provides feedback on the success or failure of message processing. Handles acknowledgements and negative acknowledgements received from RabbitMQ. Checks if the received frame is an ACK or NACK. If it's an ACK, extracts the delivery tag from the frame and removes the corresponding message from the message_map dictionary. Prints a success message. If it's a NACK, extracts the delivery tag from the frame and removes the corresponding message from the message_map dictionary. Prints a failure message. This summary provides a concise overview of each function's purpose and their order of execution within the code. Perform_batch_processing establishes a connection to RabbitMQ, creates a channel, enables publisher confirms, declares a queue, registers the acknowledgement callbacks, defines message batches, initializes the message_map dictionary, and initiates the batch processing by calling handle_batch_processing. Handle_batch_processing channel batches iterates through each batch, calls publish_batch to publish the messages, and waits for all confirms in the batch to be received by processing data events using channel.connection.process_data_events. Publish_batch channel batch publishes messages in the batch to the my_QQ using channel.basic_publish. It sets the delivery mode to make the messages persistent, keeps track of the published messages using the message_map dictionary, and provides feedback on the success or failure of message publishing. Handle_confirmations frame handles acknowledgements, ACK, and negative acknowledgements, NACK, received from RabbitMQ. It checks the type of acknowledgement received, removes the corresponding message from the message_map dictionary, and provides feedback on the success or failure of message processing. Perform_batch_processing, the main function that calls perform_batch_processing to initiate the batch processing. Exception handling for publishers. Publishers may encounter two types of exceptions during their operation. Network I/O exception. This type of exception occurs when there is a failed write or a timeout during network communication. The occurrence of this exception can be immediate or delayed, depending on factors such as network congestion or packet drop rate. It is important to note that different programming languages may handle exceptions in different ways, but the discussion and recommendations in this section apply to most client libraries and programming languages. Acknowledgement delivery timeout. Publishers can also encounter exceptions related to acknowledgement delivery timeouts. This type of exception occurs when the application developer specifies a timeout value for receiving acknowledgments. The appropriate timeout value is determined by the developer and should not be set lower than the effective heartbeat timeout. Immediate and delayed occurrence of network I/O exceptions. Network I/O exceptions can occur immediately during a write or with a certain delay. The delayed occurrence is typically associated with I/O failures caused by factors such as high network congestion or packet drop rate, which may take time to detect. If the connection recovers after a network I/O exception, publishing can resume. However, if the connection is blocked due to an alarm, further publishing attempts will fail until the alarm clears. More details on the effects of resource alarms are covered below. Effects of resource alarms. Resource alarms can impact publishing by blocking the connection. When a resource alarm is triggered, further publishing attempts will fail until the alarm condition is resolved. It is essential to understand the specific effects of resource alarms and implement appropriate handling mechanisms to ensure smooth publishing operations. Setting a reasonable timeout value for acknowledgement delivery. Developers have the flexibility to set a timeout value for acknowledgement delivery. It is crucial to choose a reasonable timeout value that suits the requirements of the application. The timeout value should not be lower than the effective heartbeat timeout to allow sufficient time for acknowledgments to be received. Note that the specific implementation and handling of exceptions may vary depending on the programming language and client library used. It is recommended to refer to the documentation and guidelines provided by the respective client library for more detailed information. Remember to handle exceptions appropriately in your code to ensure robustness and graceful error handling in your publishing operations.